Okay. So Inria, French National Research Organization in Computer Science, and Universite Paris-Saclay, which is the largest university in France, and I'm a professor there as well as a research director at Inria. And I have a joint lab between the two of them. And my group is called Exitu, for Extreme Situated Interaction, Interaction Située. And we work with both creative professionals and we work with people who are involved in safety critical systems. And we develop a bunch of new design methods. I have a book that I just gave a tutorial about at the Mackay conference, and it's called Do It, the Design of Interactive Things. And there's a longer book coming on, but it's really a lot about how to do HCI methods from the beginning to the end. And the idea is that when we work with extreme users, they push the limits of interaction, which is what we're interested in, and extreme environments that push the limits of technology. So that's just a quick summary of what we do. We have 4 basic research themes. The way we work in France is that we have a group of faculty who are all together. So I have 5 faculty members in my group at the moment. It's gone from 4 to 9 and back down and up and down as people leave and start their own research groups. But we have a much more collaborative kind of environment than the sort of typical North American view. We have 4 different research themes. Fundamentals of Interaction is really about the theory behind interaction. Collaboration, we have a large projects getting started on collaboration, and we've been doing that for a while. Creativity support, and human-computer partnerships. And I'm going to start with the last one today. Well, no, I'm going to start with the first one today. So we have this thing called generative theory. How many of you are working in human-computer interaction? I know this is the HCI seminar, but how many are you actually doing research in that area? Okay, so some of you, but not all of you. So one of the things that I want to talk about today is how do you think about interaction as a key element of human-computer interaction? How do we focus on that as a phenomenon in its own right? And how can we do it in a generative way? How can we be inspired by theory that leads us in new directions? So I'm going to cite this paper that we just published at Mackay in 2021 with my colleagues Michel Baudouin-Lafont, who happens to be over there, Susanne Bodker from the University of Aarhus, and me. And we want to think about what does it mean to do generative theory. If you're doing research, and you should all pay attention to this, this will be useful to you if you're doing a thesis, if you're doing a master's, whatever you're doing, think about this, okay? If you look at the natural sciences, you have 2 different things that happen. You have formation of theory, and you have empirical observation. Formation of theory is often done where you talk about a theory, you test it with an experiment, and then you go back and you revise your theory. And there are a variety of sciences, natural sciences, that work that way. So if you're in physics, for example, or if you're in biology, you might have the DNA, the double helix or something. You say, okay, we have this idea of how the DNA is structured, and we're going to go and do studies of that, and then we're going to go back and revise it based on our empirical understanding. But there are also other equally legitimate sciences, natural sciences now, that start with empirical observation, develop theory, and then go back and test with observation. So in those cases, you have things like astrophysics, you have geology, you have anthropology. Those are cases where you have to look at the real world, and you want to get the richness of the real world. So what's really interesting in HCI is that we have both of these, and research in HCI deals with both, but there's something missing, all right? And what's missing is the fact that we're dealing with artifacts. And we're dealing with artifacts that we create ourselves. They're human-created artifacts like this. And there are physical properties to this that I can study. But the whole notion of interaction with technology and these artifacts that we create has to be dealt with in a slightly different way. This is what Herb Simon talks about in the sciences of the artificial. We are doing science, but with respect to created artifacts. They're not things that exist independently of us. They're things that we're involved with. So now what that means is that we have in HCI this theory, empirical observation. We look at users. We create theories about what should be going, good ways of designing things, and then we actually build technology. And my argument to you, if you're doing research in HCI, is that you should be doing a complete path. you should be going from theory through artifact to observation and back up to theory, or you should start with observation, go through design and up. If you're just going across the middle, you're in industry. That's fine. That's good. You're just not doing research. And there are people who do things like, a lot of AI is going from theory to artifact, theory to artifact. That's one kind of thing. There's other people who go from observation to design. It's a different thing. But to do research in HCI, I will argue, there will be people who disagree with me, but I will argue that you should do the complete path. Now, another way of looking at this is that we have a set of design methods, and again, that's what this book is about, and the other kinds of things that we do. How do we interview people? How do we do a generative walkthrough? How do we think about gathering information from users and having that influence our designs and then figuring out whether those designs work? There's a lot of that in HCI, and there's a lot of that in UX design. Some of it more rigorous than others, but basically there's a lot of that. What's often missing is this bit. How do we think about theory, and how does that inform our design? How do we do what we call generative theory? Now, if you look at theory, depends on which discipline you're coming from. I'm a kind of weird case because I started out as an experimental psychologist. Then I spent a bunch of time with anthropologists and sociologists. I spent a bunch of time in computer science, spent a little time in management, worked in industry, worked in academia. I've just gone back and forth and worked with lots of different people. And what I learned in that is that the shape of theory matters, and it's different. So we have descriptive theories, and that's what you do when you're trying to, you see a phenomenon out there and you want to describe it, and you just want to see if it matches. Then there's predictive theory, which is I can understand what's happening here, but I can predict what will happen next. And there tends to be a more quantitative element to that, but not always. And then there's the notion of control. So if you come from behaviorism, for example, you're controlling human behavior or animal behavior. If you're going to train your dog, you want to control that behavior. That's a different path of theory. What we're talking about is something that's a little bit orthogonal, which is what we call generative theory. The idea is that we have theories that we can take from different places and use them to inform our design. So the idea of a generative theory of interaction, which is what's in this paper, is that we take empirical theories that exist outside of HCI. They can come from psychology, sociology, evolutionary biology, you name it. But the problem we generally have is those are broad theories, and the researchers who create those theories do not create them with the idea of helping us design artifacts. They just don't. It's not their goal. They want to understand the world. They're natural scientists in that sense, or social scientists, but their goal is to understand the phenomenon. So what we need to do is we take the next step. We start creating and developing concepts that allow us to articulate what's relevant from those theories that are well established, but relevant to HCI. And then we create a set of generative principles. These are actionable principles. These are things that we can look at specifically and say, if I follow that principle, I can take advantage of the knowledge that they've developed in these other fields and apply it to my design. All right, so how do we do that? Well, we argue that you can start with existing artifacts and apply an analytical lens, which is to basically take these analytical principles, look at that particular piece of technology, and figure out whether it's even there. The next thing that you can do, so that's that, and it's kind of like, is it there? The arrows go slowly. And then we can have a critical lens, which we can apply both to things that exist and also to new things. And here the idea is, would the system be better off if we use this principle? Can we put a value judgment on it? And here, basically, that can help us think about improving an existing system or creating a new one. And finally, we have a generative lens, which is how can we use these principles to actually create something that's new. And we find that this is an extremely powerful way of creating new technology and new ideas. So in the paper, we have 3 examples. There's instrumental interaction, which is something that we use a lot. This is based on human tool use and technical reasoning. The one I'm going to talk about today is human-computer partnerships, which is also another name for the more precise name is reciprocal co-adaptation, but I'll get to that in a minute. And the grounding theories here are coming out of evolutionary biology, the way species and animals co-adapt. Not co-evolution, co-adaptation starts with Darwin, has been elaborated since, and the notion of the adjacent possible, which is, in a nutshell, if you imagine you have a single-cell organism, there's only so much you can do around that. You're not going to go from a single-cell organism to a human being in one jump. It doesn't happen. But if you have two of these and they get glommed on together, now I have a multicellular organism. Or maybe I have a nucleus inside. And once I have the idea of multiple ones, then I have what's called I've made the adjacent possible bigger. So by having these theories, I can build on the set of things that are possible so that we can make a larger and larger design space for creating this. Okay, so that's what we're going to talk about a little bit more. And then Susanna's work is much more on a larger scale with community and common objects based on activity theory and artifact ecologies. But I'm going to focus on human-computer partnerships today. So let's think about what's happening when we're talking to computers. Three basic oversimplified ways of thinking about our relationship with a computer. I can think about me interacting with this as a tool. And that's basically where we've been historically in human-computer interaction. We think about creating interactive tools that we can apply and use to solve different problems for ourselves. And a lot of what we do is create those tools in this field. Another one is the idea that we tell the system to do something for us. We delegate responsibility. And that's where a lot of AI is these days. And a lot of this sort of notion that the human doesn't have to do it, we're going to delegate it to somebody else, has a lot of implications in terms of how we think about interacting. And finally, there's the notion of computers as a medium for communication among people. Obviously, social media is an example of that, and this course is a hybrid course, and so some of you are at a distance. That computer is serving as a medium for us to communicate. Even though I can't see you, you can see me. So when we're dealing with that, I also want to say that we're not dealing with computers in the simplest way. We can think about how to place this technology with respect to the human being. It can be something that you wear. It can be something that you augment in the object itself. You can also augment the environment. These are all different ways that we can create for doing different styles of interaction. Now, I'm going to come in and be rather critical right now about the way that AI research is being done today, which I object to. Not because I don't think that there's some incredible potential for AI, but because the way that the research is done does not think enough about the role of the human being. So a lot of AI systems that we see are changing the way human beings interact. I'll give you an example here. So just so you know, Dad's in prison. What? Are you joking? Why are you answering your phone? I'm freaking out. Okay, why not? So what's happening is the person's replying, oh, wait, I mean, you know, Dad's interested. Sorry, I was in the bathroom. Dad's interested in going to dinner tomorrow. Oh, you just took 5 years off my life. Thank you to autocorrect. All right, the problem that you get here is not how clever the algorithm is, but the way it's presented to the user. And it's correcting things for you. You've not consciously, but sort of unconsciously delegated the task of fix my writing. It's fixed it, and it's fixed it in a way that's really wrong. And it's not very smart about people. It doesn't know that that's a stupid thing. There is no such thing as stupid or not stupid on the AI side. And so what's happened is that we have moved as human beings from being authors. So when I'm speaking to you, I don't have a little thing in my head saying, oh, you should say this next, you should say that next. The most I've got is my slides, which do prompt me. But it's not I stay in control. But if I'm typing, the system is taking control, and it's doing things. And I have to actively shift and say, is that the right thing? And I let it go out, and I'm just a very different role, okay? So when we're thinking about dealing with AI systems, we have to think about how is that embedded in real-world context? How does that make us interact for better or for worse? And it matters what those errors are. It can help us, even something that is 99% right, which these are not, if that 1% of errors is really going to take us a huge amount of time to fix, that can be worse than not having it at all. So we should be paying attention not just to the algorithm, but the way it's embedded in real technology that we human beings use. Now, part of the reason for this is the way that machine learning algorithms and all of that stuff work. There's basically the idea is that you assume that there's some kind of ground truth, which may or may not be true. You read your data, you calculate it, you find some patterns, and then you produce the result. And it's very linear. You know, I send you something, calculate, send it back. But the problem is, when you do that, when you think of it that way, it's very tempting as an AI researcher to define the user's role as either a source of data to help your algorithm, because you're getting measured on the quality of your algorithm, not the interaction, the quality of the algorithm. So you want better data for your algorithm, please. Or a source of error to be resolved. So if you look at people in cryptology or cybersecurity, they're the ones who are talking about, you know, the main source of error is the person in the seat, in the chair. Users as a source of error, really annoying, messes up my algorithm. And you can also think of it as just basically another component of the machine. If you're doing neural networks and you say, great, I've got this wonderful neural network and the human brain's just like that, and it's all one big sheet. But none of those are very productive ways of thinking about it if you're doing an HCI perspective. You really want to think about what is the impact on the user. So there's a number of things. I won't go into detail on all of this, but basically there are a lot of issues in who is creating the data. So if you here at Stanford are getting a really nice rapid response to something and you get your coffee a little bit faster, or you get your, you know, reference to that research article a little better, but there's somebody in Kenya who's working at $2 an hour who is being forced to be in a situation where they're dealing with toxic information, is that a good balance in terms of how we deal with interaction? I mean, because there's lots of people involved in these things at very many different levels. There's other things where, I've studied this a lot, it's the Boeing 737 MAX, you may have heard about this. This is the one where they, by the way, how many of you think that aircraft have a lot of AI in the cockpit? Put your hands up. Put your hands up if you think so. Because the answer is no. They don't. They really don't. They have to go through a certification process and so on. They're automated. They are not intelligent. And when they put in intelligence, like in the MCAS system here, this is basically a detector, and you've got the nose of the aircraft going down, and if it thinks that it's doing the wrong angle, it pulls the nose down because it thinks you've gone up too high, except that it can be wrong. And Boeing did it so it didn't have any replications, just one source of error when it went down. And you had 14 seconds, the pilot had 14 seconds to fix the problem. And we have 2 deadly fatal crashes because of this. So this was AI being introduced with the assumption it's correct, without telling people it existed, without training them. And it shut down Boeing and those planes for 2 years and cost, I think, what, $20 billion in fines? Massive, massive error. So we have to be careful in any kind of safety critical system about how we're going to do this. Now, another thing that I want you to think about as HCI people who are going to sometimes be doing AI yourself and sometimes working with people who do AI, is keep in mind that a different algorithm with the same interaction can produce the same result. So what matters overall is the interaction. And we have a project on sustainable AI, and the idea is, can we use less intensive algorithms to get the same result from the user's point of view? And similarly, and very importantly, the same algorithm with a slightly different interaction can produce radically different results on the user. Classic example, not a classic example, a good example. Think of ship captains going into the harbor, and they've got to plot a route into the harbor. And they've got this nice AI system, and it comes in and it tells them a route. And it took them about 2 weeks before they just said, nope, 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 nope. Because what it's doing is de-skilling them. And they don't know why it produced that thing. Same algorithm, same system, different interaction, slight difference. Now the pilot the captain plots the course first, and the system comes back and it says, okay, that's good, but you could have done this and you could have done that. And then they're evaluating their own work with respect to other possibilities, and they are thinking about it. Now we're upskilling. Now we're making them better. Same algorithm, different interaction. Interaction matters. Okay, so keep in mind that a better intelligent algorithm is neither necessary nor sufficient to create a better intelligent system. So we have a large group of people who are working on better algorithms. More power to them, let them do that. We will use the results of their work. But it's critical that we think about how we interact with those algorithms. Otherwise, we create all kinds of problems. Okay, so there is this notion of human in the loop. Here the idea is, the perspective from AI is we're going to measure success. If you go to a NeurIPS conference, you're going to be measured on how good is your algorithm. Did it perform better? And what I suggest we should have is something closer to computer in the loop, where we think about the measure of success is the human being better off? And that's a critical shift. It's not necessarily fundamentally different in terms of that loop. It's still a loop, human, computer, but it's a different way of thinking about it. The other thing is that we want to think about interaction over time and the fact that people change their behavior over time. And this is starting to get to this idea of human-computer partnerships. So there's an interactive loop, and we're responding, the computer is responding to the user's actions, but the user is also responding to what the computer does. All right. Now, I want to say one last thing, which is from a research perspective, we are always facing a challenge, which is when we're trying to design a new system, we want to give the user the maximal power of expression, number of different ways of doing things and giving them a powerful way of doing that. Programming languages do this really well, but they're not easy to do, right? Now, what you get in contrast is what's on your phone. This has a lot of buttons, and those are easy to push, but very low power of expression. So we have this compromise between power of expression and simplicity of interaction. And I would argue that that trade-off is always there. However, as researchers, we have a challenge, which is, can we move that curve? We can't get rid of the trade-off, but we can move the curve. So we can do things where we keep simple things simple, and we allow complex things to be possible. And for a system that's this level of complexity, in terms of power of expression, can I make it simpler? Or can I add power to something that's that level of simplicity? And we have a number of different examples of that in our, you can look on our website if you want to see some examples. So how do we create interactive systems where we have AI integrated? So we want to combine this idea of the computer as a tool. It's an interactive tool that we can manipulate and do things with. And we want to think about how we can use those tools to augment our human capabilities. And we can also take advantage of the computer as a servant and being able to take over certain tasks that we want to do. But the challenge, I maintain, is to keep the user in control. So we want to not treat people as a source of data for the algorithm, but basically consider algorithms as a source of information to the user. And I don't mean explainability in the traditional AI sense, which is like, let me explain this algorithm to you, because most users don't care. It has to be understandable, a source of information relative to what the user wants to do in the context of their particular work. All right, so how do we empower users? How do we help them gain skills? How do we help them control the interaction? Well, I argue that we create these things that we call human-computer partnerships. And the idea is to take advantage of the best features of both, because human beings and computers are very different. They have some shared skills, but a lot of very different capabilities. So let me think about what do I mean as a metaphor here for what is a partnership. So if you think about taking a taxi or an Uber or a Lyft or whatever, you say, I want to go to that place. And say it's been Saturday night and I'm out drinking and I really shouldn't drive. I want to delegate the driving to somebody else. And so a taxi lets me do that. I can give that control over to somebody else. And I just give them the address and hope that they'll get me there. By contrast, you have something where you really enjoy the type of transportation you're doing. Say driving a motorcycle. You've had to learn how to ride that motorcycle. You had to get certified and so on. But you really like going out on a Saturday afternoon and going through up to Marin County or wherever, and you're riding around and you're having fun, right? That's great. You maintain control. But is there something that lets us do both? And I would argue that the metaphor here is one of a horse. So a horse is intelligent, but not the way you're intelligent. But they can get you places. And they can take you home if you're drunk, because they know where home is, if you're close enough. But you can also go jumping and riding and do things with that. And the idea is that you can learn, both of you learn to each other, you adapt to each other, you learn to get better riding the horse learns to interact with you and learns things from you. And the idea is, can we create partnerships that have some of these characteristics, where there's some intelligence that's different from our own, and our own intelligence, and we can learn over time how to control that interaction. Okay, so now human-computer partnerships is the marketing term for what we call reciprocal co-adaptation. And co-adaptation, as I mentioned before, comes from evolutionary biology, but it's been applied to how we co-adapt with technology, not with species and individuals co-adapting in evolutionary biology terms. So the idea is that there's 4 different relationships you can have. I, as a user, can adapt to the technology that's there, which means I adapt my behavior, I learn how the system works. And if you're in UX design, you're always thinking about, create the user experience. And it's this very simplistic kind of, okay, that's one thing we'll do. We will let people learn the right thing. Actually, I realized that I should have had all 4, so I'm going to have to say the 4, and then the other thing that you can do is you can adapt the technology. You can appropriate it. You can change it. You can make it different. And so if I have, for example, this water bottle, this is great. Oh, I'm glad I have a water bottle. I can use this to drink from, but I could also use it to prop up this book. Right? I can adapt its properties. This is the notion of affordances, which I'm sure you've all heard about. But the idea is that there are properties in the physical world that we can take advantage of, and we always use those properties and manipulate them to make things happen the way we want to. So we are adapting the world around us. It's a phenomenon that happens in evolutionary terms and on local terms. And the thing is, we can take advantage of that. Now, that's co-adaptation from the human perspective. Interestingly, you have the reverse, which is the system can learn from us as users. It can collect data about us, and it can figure out things about us, and it can modify its behavior according to what we do. The other thing it can do is it can manipulate our behavior. It can adapt us. It can appropriate how we're working and make us do things. Now, that can be good. We learn stuff. It can make us learn things. Or it can persuade us to buy things that we probably shouldn't buy. So there's a whole set of principles from experimental psychology, and particularly behaviorism, about how to control human behavior. So there are 4 different things going on in reciprocal co-adaptation. And I'm going to now start showing you some examples. All right, so these can be, in the simplified version, discoverability, discovering how the system works, appropriability, how to change it, and expressivity, and that goes both from the human side to the system and the system side to the human. All right, so we want to adapt to the technology, how it works in context. Here's a very simple example. So if you think about this as a phone, right, this is a very powerful computer. Extraordinary computer. If my usual example is the computer that put a man on the moon is way more powerful than this, right? This is an amazing thing. In terms of your hands, you have a huge amount of dexterity. I can take this off. Maybe I can take this off. Can I take this off? Yes, I can. Look at that. All right. Thank you for the water. So I can sculpt things, I can paint, I can write, I can do all these different things. But then if you look at the interface here, all I'm doing is touching things. Maybe I swipe, I slide, I poke at a menu. It's very, very, very limited interaction. So how could we make interaction much more rich? Well, we could use gestures. Still very simple relative to all the things we can do with our hands, but still pretty interesting. All right, so why don't we do that? Well, because we forget. We forget the gestures, right? We need to learn them. So we have this idea of doing progressive feedback. What gesture have I already done? Discover what the system understood about what I've already done. And progressive feed forward, which is to identify what's possible. And here in this example, the width of the path shows me sort of how likely it is. We'll see this in a second. So this is an example. If I want to do the question mark gesture and I don't know what it is, I can pause here, and it shows me a number of different possible paths, and I follow the one that I like. Let me just keep going here. So what's interesting is that if I'm an expert, what I want to do is do it quickly. If I already know it, just don't slow me down. Let me just do it. But if I'm a novice, what I do naturally, without thinking about it, is to pause. And when I do that, then I'm indicating to the system, hey, show me what's available here. And what's nice about that is it's both unconscious, it does the right thing when I'm not thinking about it, but it also is something that I can be conscious of, and I can choose to put my finger down and pause, and it will do the right thing. So here we have this example. This is implemented on a phone, and we have a set of things here. And we can call Alice, so this is this thing here, and you notice that it gets thinner and then disappears, so the set of options disappears as we get further along in the algorithm. And so we just go here, and here's somebody doing it with a partial. Here's intermediate, you only pause in the middle of the gesture, and so on. I'm running really far behind, so I'm going to just zip. I think you've got the idea. We have other examples. This is one I just particularly like. So we studied authors, professional writers, and we discovered as part of our work with them that they like to hear their dialogue voiced out loud, and they actually record that dialogue, and they sometimes go off and do it. They also procrastinate, but they want to do what they call creative procrastination. So the idea here is very simple, and it's the same principle that you just saw. Imagine that there's a little coaster here called the Sonami, my sound friend. It's a coaster, and it detects whether the coffee cup is there or not. So the idea is that when I take a sip of coffee, it means I'm taking a break. And so that's a nice time to launch the audio, and it plays the sounds in my dialogue. So it's a case of, and I can intentionally do it and play a bunch of them, or I can turn it off. But the idea is that I can maintain my flow of activity and have these lightweight little things that are integrated into the flow of activity. All right, now I said co-adaptation has 4 principles. The second one is that users can adapt the technology in different ways for their own needs, what we call appropriation. And here, we can do that in a very explicit way, which is like defining your own commands. So here we have a way of personalizing gestures. And say I didn't like the set of gestures that I saw before, I want to make my own gestures. How would I do that? Well, we have this compromise that we have to make. From the user's perspective, I need to make gestures that I can easily remember, things that make sense to me. And the system has to distinguish among these different gestures. And if you think about it, like if I say, here's a circle and here's a square, for me as a human being, I can easily distinguish that. Most algorithms cannot. But if I make a line like this or a line like that, the system can easily distinguish those two, but I think of it as just a line, unless I know something about the algorithm. So we have these things. We have to make it clear to the system and to the user what is an appropriate kind of gesture. So we put a heat map up, and we have blue means the gesture has been recognized, is distinct from everything else that's in the vocabulary, and it's a good gesture to use. Purple means it's ambiguous, and red means don't stop there because that gesture is too close to something else. So we have an example here. See if we can, yes, if you can adjust the sound a little, that's sorry. Okay. All right, I'm gonna. And then. right, I think I'll stop there because it's very loud. And this is an example of the gesture going up. It ends in red. That tells me, nope, that one's already been taken. But if it goes down and ends in blue, that means it's fine. OK, there we go. And then go back down. Right, 2 different gestures. OK, so another thing that we can do, and I'm going to have to speed up a little bit, modify your input to create expressive output. So we want to take advantage of the fact that human beings operate in different ways. So if I'm writing on my phone and I write a gesture type and I write something on my phone, the output will be in exactly the same font as everybody else's. But if I write handwriting, you can see that there's a lot of distinction there, right? And you can see that this poor kid basically did all the I's, I will, be, and then thankful for what I have. Anyway, there's information that is in there because we as human beings are putting things in a particular way. So the question is, how do we capture that? How do we let people do that? How do we add a personal touch? So many of you may know about swipe typing, gesture typing. The idea here is that there are very clever algorithms. Shuman Jai is the one who did this originally, and this idea that if I want to say the word pepper, I can have it go down, go up, go all the way around. All of those are very cleverly identified as the same thing. So from an algorithmic point of view, it's very, very powerful. However, the outcome is always the same. In each of these cases, you can see those all say the same word. Now, what we wanted to do is take advantage of gesture typing, which is 40% faster than tapping on the keys, but allow people to take advantage of the variation. So what's happening in that algorithm that you just saw is that all the human variation is thrown away. It's treated as noise, and noise is unwanted. There's the right way of doing it, the ground truth, this is it. Any variation is bad. The alternative is to do what we've done here, which is we keep the recognizer as before, but we also interpret different characteristics of each gesture. We map that onto characteristics of the final output. So we can do R and G and B, which is curviness, inflation, and speed variation. We map onto red, green, and blue, and we can get the entire set of colors just through gesture. We also map it onto a font. For example, we worked with a professional choreographer, not choreographer, typographer. We also work with choreographers, but in this case, typography. And this is what I can't turn the sound down, but if you can turn the sound down, that would be great. Oh, is this? I'm worried about. All right, you get the idea. It's not on though. Okay, thank you. That's better. All right. I feel like I'm being a little redundant here. So you can see here that she's just typing, she's just gesture typing, but she's controlling through how much effort she's putting into it, the output. And you can see here this text. Right. Anyway, I will keep going here. You get the idea.
We can map the curviness of a gesture.
Right. I think. Anyway, there's a variety of different things. We've also implemented this in something called Command Board, which is a way of giving you the power of a command line interface or interaction on a soft keyboard. And here we can transform any gesture-typed word into a command that is then automatically interpreted. And what this lets us do is we can take advantage of the things that we've talked about before. So this is the octopocus thing, and this is, I'm doing here, I start writing the word brightness, and then I can adjust the brightness. It gives me that. This is a font, and I can change the font. I can do a marking menu. We have a variety of different ways of basically using this space here as the keyboard entry, and here is an output space, but we've made that interactive. And so we have this whole way of creating an interactive space. All right. I'm going to not show that. Another one that we've done is working with choreographers and dancers, and the idea is that they create individual sketches of what they want to do, and then we have the ability to do something called notation, where we transform their sketches into interactive elements that they can manipulate here and see. So let's see if we can get that working. So here's somebody drawing. And this is the layout of how they would do this on the, on the floor of the stage, and then how they operate together. And then here are some of the choreographers who are actually showing their actual work. And we can embed video in there, and they can dive in and do various things. So there's lots more to say about that, but I will just keep going. Another thing that we can do is we can think about teaching machines. So this is basically, how do we think about the role of a data scientist who is teaching a machine's algorithm? The assumption normally is that they're experts and they'll just do it, and it's fine, and we don't pay attention to that interaction. But it's actually a really important interaction. And when you have a domain expert who doesn't understand anything about how algorithms work, you have to think about what you're going to teach them. So here we have the idea of helping a novice. So it's an expert in the domain, but a novice with respect to machine learning. And how can they understand the strengths and weaknesses and teach an interactive classifier? So there's these different types of ambiguity. There's aleatoric, which is ambiguity and noise, and epistemic, which is here. We'll do that. So aleatoric is if I'm trying to distinguish a dog and a cat. If I show a photo with both a dog and a cat, that's noisy and it's ambiguous. And that's a different kind of uncertainty than showing a photo of a completely different animal, which would be a panda. So we have this system. What we're trying to do is get them to train a classifier to distinguish between different playing cards, and then show them the different types of uncertainty. And what they do is they get better at creating training sets for teaching the algorithm to distinguish the right kinds of uncertainty. And again, I'll go fairly quickly through that. So there's an example of showing the training example. If they then show an example with two cards that are ambiguous, that's a different kind of uncertainty. And there's an example of putting your hand in there, and that's yet another type of uncertainty. So the idea is thinking explicitly about what's going on when a human expert is trying to teach these algorithms, and that's another area that we need to play with. All right, another one, the system adapting to the user, the system learning. I'll do this quickly, I hope. So we did work with graphic designers and all kinds of different designers working on mood boards. And the idea is to think about how you share agency between the user and the system. This was done before ChatGPT and all these things. It was done in 2020, and it feels like forever ago. But anyway, we have the user in control, which is basically working with curated sets of images to try to create your own mood board. And in this case, we just have a cascade of images, and they get to choose different images and look at different things and so on. So that's basically what you would expect. And then they're going to create the mood board on the right. The next thing you can do is have something where the control is really in the hands of the AI system. And the agent is looking at what the user has already done and suggesting images based on that. So this is based on a thing where you can see that they can request more like this. Now, what's happening is that they can search with images, they can search with text. It feeds back a tag cloud that says this is what these images are looking at. So we're providing a lot of information back and forth between the user. The user can use combinations of words and images to search, and then backwards the other way. So the last one is shared control. This is the user and the agent each searching images together. And this is something called semantic collage. This is all part of something called image sense, but this particular bit, as you can see, searching with images, because we found that graphic designers don't like to type things. They like to search with images. They think visually, so we give them the ability to do that. We also give them words back that they can say more of this, less of that, and they can identify elements of the images, reuse their search history. And so what they're doing is this dynamic back and forth between images and text and what the system is suggesting and what they're suggesting back to the system. So really trying to create a shared controls, shared agency. All right, the last one is the system can modify the user's behavior. So it's teaching or manipulating the user. Here, we're using principles that come out of experimental psychology. And the idea here is we worked with a theater company, and they built this wonderful, magnificent Christmas display that was up in a shopping center for a month. And we have a couple of other installations. And the idea is that somebody comes up, and they want to manipulate Santa and make Santa do a particular move. Now, we want to teach them to make the right kind of movement, but we don't want to use words, and we won't even tell them that they're being manipulated. So we created this wonderful machine here, and so the reinforcer is to make that machine move, and I'll show you that in a second. And what we do is we create an interactive experience with the user where they are interacting with the little Santa Claus figure here, and they share control with the system, and the system is shaping their behavior. It's, again, a psychology term. This is what it looks like. That's making that thing go is really fun. So if you're in a shopping center and that's the thing, kids love that. You get the idea. And then here's Santa just sitting there in the middle, and he just sits there, and then if you walk up to it, he'll stand up and he'll start following what you're doing, and there we go. All right, so what we have is a system where we're using principles from psychology. This is, again, a generative theory, so we're using this theory to help us control movement. So we want to have a way of indicating to the user that they're making progress. So we have these 3 sets of stairs, and they figure out very quickly if Santa mounts the stairs, he can pull a lever, which is both a virtual lever and a physical one, and launch the machine. And if Santa gets bored because you're not doing something interesting, then he goes back down or he falls through the floor and the whole thing stops. So the idea is that we want to find the correct movements through trial and error. And we start out by drawing them in, and we mirror their behavior. That gets their attention. So if I go like this, Santa does this, and he follows me for up to 30 seconds. But at that point, then Santa starts doing this. And now what we're doing is taking advantage of something called extinction behavior. So Santa stops paying attention and starts looking bored and wants me to do something else. Now what happens is, if you stop getting reinforced for doing something, you don't just stop. What you do is you start making lots more behavior. And when you've got lots more behavior, then we can shape that behavior. This is exactly what happens. And so what we do now is Santa starts rewarding behavior. So our thing was to try to get people to make their hands over their head to do this. Just random people coming in off the street, and within a minute and a half, we get them doing this. That's our goal. And so what he's doing is Santa is rewarding successive approximations to the final behavior. So first, any movement is good, then any movement that's above my shoulders, then any movement that's up here. So how does this work? Well, we have a very simple system. We have a skeleton that is being drawn from a Kinect. And so this is the Kinect here. This is mapping whether it's good or bad, and she's doing this. She's a little bit bored. She kept coming back day after day. But she knows that Santa will just follow her, so that's like not interesting. Okay, we can do that. Now she's doing that. But every movement she makes. Now once this comes up, now she knows she's got to start figuring out what kind of movement. And we've got it programmed on the right here, and we're continuing here. So we're mapping what she's doing. Notice that she's sometimes got her hands above, sometimes not, so it's a little ambiguous. But then it's getting closer, getting closer, getting closer. She's going to do it. She's trying harder and harder, harder. No, she's trying harder. And then it's going to go. Come, come, come. Yes. You go up. Now she does my favorite thing, which is, yes, she's doing, yeah, that works. That works. Santa likes that one, so Santa's going to go and launch the machine. Come on, Santa, go. All right. So, yes, and then that launches the machine. Now, what's interesting about this, and I'll just show you her, because it works with even really little kids. It's just it's a lot of fun. Even when her little brother comes up, or another kid. There we go. Come on, come on, come on. It's coming. And then you see virtual one, and it starts going. There we go. All right. So I think I'm going to skip through the last bit and just say very quickly, When we think about how to deal with HCI and AI, we need to think about it at different levels of scale and different levels of time. We need to think about how do we measure human behavior and how do we take advantage of different kinds of relationships. And again, we can be inspired by evolutionary biology and the idea of looking at relationships among species. We'll think about the AI as another species. What can we learn? Well, we can have a long-term relationship that is positive, neutral, or negative. And over time, that can get better or worse. And we should be tracking that. We should be keeping ways of measuring whether these interactions are positive or negative. And so we want to think of interaction as a phenomenon that you can study. We want to think about how to measure it, both qualitatively and quantitatively, and think about it in the short, medium, and long term. I did this right here. So we want to think about not just measuring the algorithm's performance, we want to think about the impact on the user, which is not always good. And we want to think about how using the same algorithm with a different form of interaction can create a different, more productive and better interaction. And different algorithms can create the same interaction. So we might find simpler and easier algorithms. We don't necessarily need the most costly one. So we want to just think about what's our future. Are we trying to just use AI to replace us? And we have this wonderful life envisioned by the movie Wall-E, Pixar, everybody's just sitting there drinking their Coke. Not really my thing. Do we want to have robots that replace us? Or do we want to think about how do we create intelligent systems that make us better, that turn us into virtuosos, that allow us to do more than we could have done by ourselves? And I'll leave you there and ask for any questions that you may have.
A few questions.
Yes.
Hey, thank you so much for this really insightful presentation. And I think it was a great counterpoint to some of the things that we heard at the WISC conference recently.
It's a different perspective, yes.
And I think a really important one. So one, thank you. It was a really good to see. I wonder if you can talk a little bit about, to me, a lot of the things that you're coming down to is about shared control or mixed initiative systems.
Absolutely.
And I wonder if you can talk a little bit about the illusion of control and sort of the challenges that we face as designers of these systems, in that people are essentially really good at making up, just like these generative systems are, people are also making up rationale for how these things work or what's happening.
Yes.
And so the classic, anyway, so.
We strongly anthropomorphize systems. And I remember way back in the 1980s, I've been doing this a long time, we built an intelligent tutor, which was not very intelligent by today's standards, I admit, but we had a little claymation character. And when he looked like a kid and spoke in a kid's voice, users spoke in a much simpler way, which made it a whole lot easier for us to interpret what was going on. And it's like the idea that, and that was at the time what they call habitable sublanguages, but the idea is that you create these environments and you can manipulate people in bad ways and good. So you can, and I think, I don't know, I think you're right. I think we constantly, one of the things that worries me about these chat-based systems is that we are so programmed to treat that as an intelligent organism, and we expect it to do things and we trust it to do things in a particular way. And even you guys, who are all very sophisticated users relative to the general population, get sucked into some of this, right? And the person who's just using on a regular basis is going to be. So, I wish I had a magic answer to how to figure that out. But I think the first thing to do is to be aware that that's fundamental to it and that we should not. So we talk, we've gone to Brussels to talk to the European Commission, and we're talking in ACM policy and doing various things, trying to get people to stop talking about controlling the algorithm and start thinking about controlling the interaction and thinking about what it is, what are we measuring about that interaction, what's the impact on human beings, and how do we legislate that in some way? Because I think we can't understand it all because it's super complicated. and highly context-driven. But I do think we should at least be thinking about interaction as something that is fundamental to what should be legislated and thought about. Yeah.
So I completely agree with all of that, and I think also Sherry Turkle's recent work
Yes.
are very interesting. I guess I'm wondering also, so that's, and again, I love your work here across many different scales. I wonder if maybe you can also talk a little bit about basically the illusion of control more in the interaction context. So we have these smart systems. For example, you talked a lot about swipe typing, where people may believe that they have agency. You have this direct interaction where you're, manipulating things, and then, but in the back there's an algorithm that pops out something. And I'm wondering if you can talk a little bit about it on a more micro level.
Yeah, on a more micro level, because actually, honestly, we mostly work on the more micro level, to be honest. But I think I feel like I want to appeal to my InfoViz colleagues, because there's a certain element of just what is it that you reveal to the user about what's going on. And part of the problem is, so for example, in the Octopocus example, the width of the gesture is getting thinner and thinner, and then it goes away, and that's revealing to the user in a way that the user can understand that the algorithm is saying you're getting further and further away from that being a legitimate gesture. And so trying to figure out ways of visualizing that, and it might be auditory visualization, it might be any one of a number of different modes, but I think we have to do a lot more of that. And there isn't a lot of research at the moment in that, but I think you're absolutely right that it's a really critical area to look at. So, other questions? Yes?
So you argued for using the paradigm of computer in the loop system as opposed to the status quo of human in the loop, right?
I'll admit that that's partly marketing. This is when I talk to my AI colleagues and they think they're doing nice things for HCI because they've got human in the loop, and I'm pointing out that, no, actually, do it the other way. So, yes, but fair enough.
And then optimizing for, rather than optimizing for the, a measure of the system's accuracy, think about how better off the users are.
Yes.
And I was wondering, and I think there are challenges to that, right?
Of course.
For example, because I don't think even the measure of what better off means is not defined or even agreed on by everybody. And I just wanted to ask your opinion or just your thoughts.
So let me give you examples that I think help, because you're absolutely right. There is no universal, this is good, that's bad. That just isn't going to happen. I don't even know if that would be a good thing, if it were possible, but it just isn't. But think about the notion of introducing the feature of like, right? And you're in a social media system, and Facebook introduced the idea that I like that, right? It has a short-term positive reinforcing effect. So if you're talking about in psychology terms, it means that, I feel a little bit better. I get to like something, or people liked my stuff, and that's great. But over time, it creates an addictive behavior, and people end up doing things just for the likes and so on. And you can go down a rabbit hole. And we've seen a really large negative effect of that happening. Now, that was pretty predictable. Any psychologist worth their salt who'd studied this at all would have predicted that, right? So there's stuff that we know is going to happen. And they basically pleaded ignorance and said, oh, we're sorry, it didn't occur to us. How would we know? So there is stuff that we can look at and at least head off or try to do it. The other thing is that we should be measuring it. We shouldn't be throwing things out into the world and hoping for the best. We should be trying to at least get some sense, based on all that we know from the social sciences, about making some predictions. And this is why I was talking about different kinds of theory. There's descriptive and predictive and control theory and so on. We should be taking advantage of our knowledge to be able to do that. I completely agree that we're not going to come up with, the perfect solution. And anytime you put a complex system out in the world, there are going to be unforeseen things happening. And actually, part of the argument behind co-adaptation is that your users are going to adapt your technology in ways that you don't expect. My favorite example is the spreadsheet, where it was originally designed, I think it was Dan Bricklin, wanted to save time. He was at Harvard, and he didn't want to add up columns of numbers by hand with pencil and a large eraser. And so he built this little thing, but he cleverly did it in such a way that he had a structure and cross-referencing and formulas embedded, and then that turned into what-if budgeting, which completely changed industry in terms of how people do things, and then you can do it to run circuits, you can make posters, you can do all kinds of things in a spreadsheet because it's got a structure that we can manipulate and adapt. And so one of the questions we face when we're building, I didn't talk about this in this talk, but the generative theory thing, the whole thing on instrumental interaction and substrates is about how we build things that users can manipulate and control and adapt in different ways. So there's lots to be said. I mean, it's a very rich question, and there's a lot. I don't know if I've answered it for you, but I think we should be thinking about that, and that's the kind of question that HCI as a field should be asking those questions. So that's a good point.
I think we're at time. But feel free to stay on and ask questions and talk to the speaker. Let's give Wendy a round of applause.